When we look up at the night sky, the question that often comes to mind is how much we truly know about what is out there and how much is still beyond our understanding. Astronomers frequently remind us that the majority of the universe remains a mystery. In fact, scientists estimate that about 96% of the universe is made up of dark matter and dark energy, forces that shape everything we see but which remain largely unexplained. It is against this backdrop of limited knowledge that conversations about interstellar objects become so fascinating and sometimes unsettling. Neil deGrasse Tyson, the astrophysicist well known for translating complex scientific concepts into ideas that reach the general public, has spoken about these unknowns in ways that resonate widely. His work often underlines how discoveries about the cosmos are not just abstract ideas, but can also hold direct implications for our future on Earth. Recently, attention has been drawn to an interstellar object called 3A, often referred to as Atlas. Its presence has become the focus of both scientific investigation and public discussion, not only because it is another traveler from beyond our solar system, but also because of the unusual features it displays. To understand why Atlas has raised eyebrows, it helps to consider what has been found before. In 2017, astronomers detected an object called Momoa, the first known interstellar visitor to pass through our solar system. It was followed in 2019 by another known as Borisov. These objects sparked huge interest because they were not bound to our sun, but instead traveled through space on trajectories that made it clear they had originated elsewhere in the galaxy. While Momoa in particular generated speculation due to its odd shape and unusual acceleration, Borisov was more typical of comets we already knew. Atlas, however, appears to combine features that make it stand apart. What has caught scientists' attention about Atlas is the way it moves and the data collected about its surface and composition. Normally, when an interstellar object comes into the solar system, its trajectory is influenced by the sun's gravity. A predictable slowing effect is usually observed, and in some cases, additional changes in motion can be explained by outgassing, where frozen materials sublimate and push against the object like small jets. Atlas, however, seems to behave differently. Reports suggest that instead of slowing under the sun's pull, parts of its movement appear to involve acceleration. The pattern does not resemble random outgassing, but instead shows bursts of motion that seem more controlled. This is one reason why it has attracted such interest. Adding to the puzzle are observations about the object's surface. Spectral analysis, a method that examines the light reflected or emitted from an object, suggests that Atlas carries a mix of materials not usually found together in this way. At times, instruments have detected metallic elements similar to those associated with planetary cores. At other times, there appear to be large amounts of organic compounds, far greater than seen in other interstellar objects so far. While it is possible this variety results from a long and violent history of collisions in space, the unusual mixture continues to challenge straightforward explanation. What makes this especially significant is the implication that such objects may not just be inert pieces of rock or ice. Instead, they may play roles in spreading materials across space that could either support or threaten life. Organic compounds are the building blocks of biology, and many scientists believe that some of the key ingredients for life on Earth may have originally arrived via comets or asteroids. At the same time, the presence of unusual or unstable compounds could equally disrupt or even destroy fragile ecosystems if deposited in large amounts. In this way, Atlas serves as both a reminder of potential opportunities for life to spread and a warning of risks we may not yet understand. Another aspect that has unsettled researchers is the way Atlas travels through the solar system. Some models suggest that its path does not look like a random entry, but instead appears to follow gravitational corridors, routes shaped by the pull of large planets and the sun. These pathways can be thought of as natural highways through space, and an object following them with great precision raises questions about whether its arrival was purely coincidental. It is important to stress that no firm conclusion has been reached here, but the unusual trajectory has been enough to fuel debate among scientists. Perhaps one of the most compelling differences between Atlas and its predecessors is the time it spends within observational range. Temomoa and Borisov passed quickly, giving astronomers only a limited window to study them before they disappeared into deep space. Atlas, on the other hand, appears to linger. This extended stay provides far more opportunities for observation, but it also raises new questions. If an interstellar object remains within the solar system for a longer period, it interacts more with planets and solar radiation, which in turn could reveal more anomalies. During these longer observations, scientists have detected faint electromagnetic emissions coming from Atlas. These are not the kind of strong, clear signals that would suggest communication, but they also do not look like simple background noise. Instead, they show patterns, low rhythms that suggest there could be some underlying process at work. Researchers have been cautious in interpreting this data, emphasizing the need for careful analysis before drawing conclusions. Still, the fact that emissions appear structured enough to suggest cycles has been an important part of the discussion. The implications of these discoveries extend beyond science alone. Objects like Atlas challenge the way humanity thinks about its place in the universe. For centuries, Earth has been seen as relatively safe within its small corner of the Milky Way, shielded to some degree by distance and stability. The appearance of interstellar objects, particularly ones that display unexpected or hard-to-explain behavior, reminds us that this security is not guaranteed. Our planet is part of a wider cosmic environment, and events occurring far away can still reach us in surprising ways. The sense of unease comes not only from the object itself but from the recognition of human limitations. Current detection systems, though more advanced than ever before, are still not able to identify every interstellar visitor before it arrives. Objects like Atlas often appear without warning, and by the time they are observed, they are already within the solar system. This lack of preparedness highlights how much more work is needed in planetary defense and in our broader understanding of cosmic processes. It is important to recognize that while speculation can be tempting, the scientific approach remains cautious. Many of the anomalies observed in Atlas may eventually be explained by natural processes that we do not yet fully understand. Science progresses by gathering data, testing hypotheses, and ruling out possibilities. What makes Atlas valuable is that it presents a real-world case that forces scientists to re-examine assumptions and refine their models. Whether the acceleration patterns turn out to have a natural explanation, or whether the spectral mix points to an unusual origin, each discovery deepens our understanding of how matter moves and evolves across interstellar distances. In a broader sense, Atlas is a reminder of the scale of time and space. Objects that travel from other star systems have journeys measured in millions or billions of years. They carry with them histories of collisions, transformations, and exposures to radiation that stretch far beyond the timeline of human existence. To study them is to look back at events that predate the Earth itself. This perspective can be unsettling because it highlights how small and recent our species is in the context of the universe, but it can also be inspiring, offering glimpses into the larger processes that shape everything around us. For now, Atlas remains under study. Astronomers continue to monitor its movement, its emissions, and its composition, gathering as much information as possible before it eventually leaves the solar system. Each new observation adds another piece to the puzzle, but it also adds to the sense of uncertainty. What we know for sure is that objects like Atlas will not be the last. As detection methods improve, we are likely to see more interstellar visitors in the years ahead. Some may be straightforward, fitting into established categories. Others, like Atlas, may challenge our understanding in ways that provoke both curiosity and caution. In reflecting on these discoveries, Tyson and others have pointed out that the greatest challenge is not necessarily the object itself, but our lack of knowledge. Ignorance in the face of cosmic phenomena is not simply an academic problem, it is an existential one. The universe does not shape itself around human expectations, and the more we learn, the more we realize how many unknowns remain. Atlas serves as a powerful example of this. Whether it is ultimately explained by natural forces, or whether it continues to resist easy categorization, it has already succeeded in forcing humanity to confront its own limitations. The arrival of Atlas has therefore become more than just a scientific event. It is a cultural moment, a reminder of how little we truly know and how much is still to be discovered. It pushes us to prepare better, to study more carefully, and to accept that surprises from the cosmos will continue to come. As long as we remain curious and committed to understanding them, each visitor, no matter how unsettling, offers an opportunity to expand the horizons of human knowledge.